We talked a little bit about people finding the book optimistic, and I wondered if the publisher, maybe, should have marketed this book as how we are going to survive and thrive in the 21st century.
I actually worked really hard to go away from the framing of we need to understand these systems before it's too late. So I spent a lot of my time with 18 to 22-year-olds, and I don't want to tell them that your entire life is going to be cleaning up the mess that the adults made. What I'm asking them to do is to build this better world for themselves, for everyone else on the planet, for all other life on the planet. And as a side effect, they will address the issue of climate change. And as a side effect, they will address the issue of pollution. And we now have, we've done so much of this work. It's not like it is the tools we need, is the pathway forward, but we have a set of tools and a pathway forward. And that's enough to get going.
Howdy, folks. I recently had the opportunity to interview Deb Chachra, professor of engineering at Olin College and author of How Infrastructure Works, just out from Riverhead Books here in the US. If you want to buy a copy for yourself, all of the links are at criticalpoint.tv/infrastructure. Now here's the episode.
Yeah, this book just came out about 6 months ago, Deb?
Yeah, last October.
Okay, yeah. And I've been trying to make this interview happen, I realized, since January, based on our email conversation. So we finally got on the call. And with that, we will roll the titles and get started. And we're back. Once again, this is the War Stories podcast with Deb Chachra. Deb is a professor at Olin College of Engineering.
Olin College of Engineering.
Olin College of Engineering. Awesome. In the greater Boston area. Remind me where exactly.
We are in Needham, Massachusetts, which is 15 miles, 25 kilometers southwest of the city.
I have a bunch of friends who went to Olin, and they all said lovely things about it. In fact, I ran into one of them at my eclipse watching party. I was like, wait a minute, do you know Deb Chachra? Because I'm interviewing her. He was like, oh yeah, I was a student of hers in one of the very early classes. And so that was fun.
Yeah, I mean, I because I've been here since I first class graduated, I pretty much know every Olin student, and certainly pretty much every Olin student knows me.
Okay, yeah. yes. Because how big are class sizes?
Well, there's about kind of 75 to 90 students every class. So yeah, and so I started here when the first class were sophomores. So that means that I've been here for every student who's passed through our doors.
For the last, it's about 15, 20 years that it is now?
Our first class graduated in exactly 15 to 20. Our first class graduated in 2006.
Okay. Cool.
So, and our 2024 class just graduated last week, just a few days ago.
You were mentioning the post-commencement quiet on
That's
campus,
right.
Which, yes, welcome, I'm sure. This is an incredibly meaty book. As you can see, if you're watching the video and it's not too blown out, I have an enormous number of sticky notes in the book, just to wayfind my way around it, because it is it's good, it's chewy, it's worth sinking your teeth into. But since we are, since the audience for this is primarily people working in software, one of the conversations that came up when we were, chatting about this over the now 5 months that took us to put this interview together is kind of what it means for something to be a system to be infrastructural, and how as software people we might realize that we have become infrastructure. I think there are some places where it's really obvious to us, people who put together the modern internet are very clear that they are building infrastructure, and whereas I think other of us find ourselves becoming infrastructure accidentally. The Discord folks who discovered that they were being used by Ukraine to coordinate the response to the Russian invasion, I think may have been a little bit surprised by that. So yeah, Deb, take it away. What does it mean for something to be infrastructure?
It's funny because, you do definitely hear infrastructure thrown around a lot, and it means a lot of different things to a lot of different people. So, Susan Lee Starr, who's a science and technology studies researcher, wrote a really great paper a number of years ago now called The Ethnography of Infrastructure, where they did a great job of laying out kind of the things that make infrastructure. And I mean, I just recommend the paper itself, but one among the things that included is infrastructure is the stuff that you take for granted when you start a project, like where you just expect to be there. Infrastructure is the stuff that most of us never think about, but other people, like their daily life is looking at that infrastructure, which I'm sure is something that's familiar to most of the people who are listening, right? To be the people who are looking straight at the infrastructure as part of their daily life. Infrastructure is typically most visible on failure because it is the thing that we don't tend to notice until that's right. It's totally taken for granted.
Yes.
Infrastructure is fundamentally relational, right? That what we, you mentioned that the people who did the internet backbone are like, oh, fairly sure that is infrastructure because that sort of underlies a bunch of other things. But, I remember talking to the CTO of our college who at his previous institution, he said, I knew that Wi-Fi went from being kind of a nice to have to being infrastructure from the first time I got a call in the middle of the night when it went down, right? That it was like the transition between, everyone uses the Ethernet lines and the Wi-Fi is like, if you just have it to no, we actually we expect to have the Wi-Fi, not just the plugged in lines. And so he was kind of like there for the transition where that extra layer went in between the college and or the university where he was at and the sort of concrete infrastructure of the networks, right? The Wi-Fi layer now just got interpolated in between. So those are just a few of the main ways in which infrastructure is infrastructure. Depending on what space you're looking at. I mean, people think about, the monetary system as healthcare, or as infrastructure, as healthcare, education, sort of social services, the legal system, right? Things like if you start a company, the things you take for granted, right? Is that contract law applies and people will be able to pay you. And so what is infrastructure for a particular, when I said like what you take for granted when you start a project what is infrastructure depends on what the project is. And so my particular focus and the focus of the book, as Kevin, as you sort of implied, is not the digital infrastructure particularly, right? My particular focus is the technological networks that make up our infrastructure. We often think of these as utilities, right? So I'm most interested in the sort of physical networks of the internet rather than like, the Wi-Fi or like the how do we figure out what the standards are, although those are closely related, water, sewage, electricity, energy, because that turns out to be the thing that underpins all these systems, transportation. So all of the things that we think about as like kind of utilities and sort of big serious infrastructure. But it is really worth, per Susan Lee Starr's point, it is really worth remembering that lots of infrastructure behaves in similar ways to things like water and sewage.
Yeah. The point you make in the book, like repeatedly, using the framing of infrastructure as networks was something that I found really incredibly appealing, partly because network theory is a thing that has interested me for a long time in the ways that networks grow and evolve. And also from having worked at companies like Akamai, where we delivered about a quarter of the traffic on the web in my era, and nobody had ever heard of us, except when we went down. And at Stripe, where we were working on payments networks and how hard, getting a three-sided network there was for the card networks to set up, and then, us interacting with that. But thinking about so I'm very used to thinking of networks in the computer context and applying that thinking to things like water and power. And, you talk about food distribution, although you make the really interesting point that water will continue flowing downhill, kind of regardless of what we do. The network, works without our continuous input of electrical or chemical energy, at least. Whereas the food network requires that continuous input of electrical and chemical energy to make it work. And so the idea that things move in networks, but the networks are more active or passive depending on the thing they're doing was interesting to me.
Yeah, I mean, that's where really the idea of these sort of physical technological networks really is important, right? Because that means I'm really focused on things like matter and energy. And if water flows downhill because gravitational energy is enough to keep it flowing downhill. That is not enough to deliver food from distribution centers to our, to our grocery stores. It's also, I mean, until we built the pipelines that bring water to where we use it because water flows downhill, right? Up until that point, it would be like, if you want to get fresh water, you could have it delivered to your house, right? And it's like, and it took actual physical labor to like bring barrels of water, right, to your house and then bring it up. And of course, people have long since tried to find ways of not doing that. And so it might be bringing water up from wells, it might be collecting rainwater.
Well, and cities are already located where they are in no small part because water flows downhill. They're, almost always sited at places where there is a confluence of water.
Per that point, everyone's always like, why is Los Angeles downtown not on the coast? And part of the answer is because when the city was originally built, the sort of the policy that the Spanish had for where they sited cities was that it needed to be at the confluence of fresh water. So it's actually the confluence of rivers as opposed to on the coast. And it also needed to be, I think their policy to avoid, for like military reasons was that it couldn't be like right on the coast. It had to be inland. So it's like, we're going to put it inland of the ocean, where there's fresh water available. So hence the LA River and like the Arroyo Seco and all of that. But also it's like why we're sort of not used to thinking of, cities on coastlines as actually having their sort of center of gravity, located inside. And then like, Mexico City was like built on, a lake, right? Which ended up basically essentially getting filled in when the European colonizers arrived. So yes, like often that's true, right? That you can sort of see how, basically because like if you have a whole bunch of people living near each other and every one of them needs water every day, and also every one of them contaminates the water, that's the sort of euphemistically around them every day. And also everyone can make everyone else sick because of waterborne diseases, right? It's sort of collectively figuring out how to deal with water is really important. And there's a reason, basically one of the things I sort of think about is, that one of the reasons why water has been around forever, right? In terms of like, as soon as basically people started living in close proximity, they started building aqueducts and reservoirs and ways to get water, is because water does flow downhill. That once you actually set up the system, you don't have to put energy into it to keep it going, which is not true as someone who works in like, digital communications. That is not true of the networks you set up, right? If they did not have a continuous input of energy, they would just fall over.
Right. The packets do not flow by themselves.
That's right. And like transportation does not happen by itself. Yeah. Right. And, but water, so the two things that you basically get for free, one is like roads, right? Is pathways, which are in fact the oldest human technology, right? That if you just keep walking where other people are walking, you will have a trail and it will be more passable. And the next oldest thing that we recognize as infrastructure is water, because if you actually build it, then water will flow and gravity will take care of it. You don't need to have input of energy. And all of the other types of infrastructure are things that really do require energy, to kind of keep going. And, so that for, most of human history, and certainly most of sort of the industrial era, the determinant of why these are networks is because networks sort of efficiently move things around with a minimum investment of energy, a minimum amount of energy. And of course, what makes digital communication different is that things like Metcalfe's law, where you're like, oh, the value of a network is related to the number of nodes on a network, right? Is kind of, you can sort of see that retroactively applies to road and transportation and transit, right? But it's funny, it was only named for the internet, or for the Ethernet rather, right? Because it was like, oh yeah, these systems are like, valuable because more people are connected. It was like, that's when it's like, I mean, this is true for phones. I think it was actually to me, it's most obvious for fax machines, right? Where if you have one, like, how many people do you know who have a fax machine, and is it like one or two or three? And it was only when you had sort of a critical mass of fax machines that it was like useful as a general purpose tool. And then of course it got very quickly supplanted, by Well, yes and no, right?
In some places, yes. Unfortunately, the state of Delaware still has a fax machine, and the state of Delaware is very important.
Yeah, and I want to say it was Kevin Kelly who said that technologies almost never disappear entirely.
Yes.
Right? They basically just become more and more niche. And so the type of network, right, the kind of water flows downhill, or the sort of last mile problem for electricity, which, really in the US, the Rural Electrification Administration was in the 1930s, right, was a way of solving the last mile problem. It's kind of a slightly different network issue, but also has a lot in common with sort of the digital networks. Because, if you think about them, as I said, as technological systems, then you think about them not just as networks and connectivity, but the nature of the kinds of networks, and also the sort of physical, the amount of energy that's required for those networks to function. And that turns out to be a really useful, to me anyway, a really useful framing that all of these infrastructural networks have in common. Not just digital networks, but also not just like the sort of, water, sewage, physical networks.
Yeah. Understanding energy as maybe the key input to all of these is something that is really valuable to me, something I've been chewing on for a while, and seeing you put it this way was like, yes, finally someone else looking at this problem from the same angle that I am.
Right. And it's also why, like, when, people sort of think about, I'm, fundamentally, my undergraduate degree is in engineering physics, but all my graduate work is in both bioengineering and material science. So, like, I sort of half jokingly, half for real say that the three things that my entire, since I was a teenager that I've cared about has been embodiment, materiality, and metacognition, because the other major thing I've done is around teaching. But also, you can already be like, how we think about things is a piece of how I think about things. And, so like really, I think a lot of the digital world is because many of us live lives where we do not have to think about the physical needs of our body because they're so well supplied by these infrastructural systems that it's super easy for us to think, oh, like everything that happens on a screen is just ephemeral, right? It doesn't take any energy. It's just moving lights, and not like actually it is like an incredibly, materials and energy intensive process. It's just that all of that work happens far away from us, right? All of the mining, all of the batteries, all of the building of things, everything that happens to them after we're done with them. And then also all the electricity that pays for that is used to power networks and data centers. None of that happens in our living rooms or our offices. So we kind of think it isn't actually happening, but it really is. So and this is, I feel like, even if you're like, oh, I do digital infrastructure stuff. And it's like, yes, the thing that underpins that, because these are physical systems in a physical world and we are material beings, is matter and energy. And being aware of where that matter and energy comes from is, I feel like it's, that sort of thing about it's like, oh, where does your meat come? It comes from the grocery store. And we think that's really childish. We understand that there is there's considerable,
I grew up in rural Iowa. I grew up downwind of a number of hog and cattle confinements, so I have a very different perspective on this, even than people who understand intellectually that their meat comes from an animal. I know what that smells like.
Right, and that's actually an excellent point, right? Like there's the sort of childish idea that it just comes from the grocery store. And so people who are just like, oh, it's like digital, it's like ephemeral, it's the cloud, right? Like the immateriality of the digital world. It's kind of like thinking that your meat comes from the grocery store, right? And then there's the sort of intellectual understanding of what it actually takes to get it to you. And then there's the real embodied lived experience, Kevin, of where does our e-waste go? Of where does, what is, mountaintop removal mining for coal? What are the impacts of the energy that's used to produce these systems? And mostly that's far away from most of us, right? Most of us do not live downwind of the feedlots. And, so that really sort of highlights that there's these kind of three kinds of experiences. And I think it's very easy for people who, to basically have it comes from the grocery store people who work in the digital field, and I see this in tech all the time, right? Have the, like, oh, it comes from the grocery store. And at the, I don't want anyone to be living downwind of feedlots and be affected by that. And in order for that, the environmental, the energy and the matter equivalent of that. And in order for that to happen, a lot more of us need to understand that the energy and matter underpin the digital world, because it's the same physical world that we all live in.
Yeah. Well, even I don't know what it's, really what it's like to rack and stack a data center's worth of servers. I know that is, an enormous undertaking, but also it all happens in Reston, Virginia. And, by the time I visited, that had been done. And, although although most of us will also never visit a data center in our lives.
Right. But we understand that there's and that's the other point, right? Not only is it the sort of energy and matter, but there's the actual human care and skilled. And this is the part, because if you're responsible for doing the maintenance and care for other people, right, you can sort of understand that, somebody else is making sure my water gets delivered. Someone else is making sure that the sewage treatment plant keeps running. Someone collects my garbage. Someone makes sure that potholes get filled. And in fact, actually, you may know that the Francis Scott Key Bridge, in Baltimore, the people who were lost in that were the work crew who were fixing potholes that evening.
Yeah.
Right. So basically, because as soon as the SOS went out, they basically stopped. It was, an incredible people responding in the moment, right? That they realized that the ship was out of control. They immediately started stopping people from going onto the bridge, so that no one went onto the bridge. And they realized that they were not able to get the work crew off the bridge. And because there was a crew literally repairing potholes that night, because it was the middle of the night, and that sort of hands-on, that hands-on labor. And I got to say, man, I do not want to hear anyone complain about potholes on their street for a good long time. Yeah. Right.
Yeah. Seriously.
After that. Right.
Yeah.
So all of these systems require significant amounts of human care, expertise, and labor to keep functioning, because entropy is a thing, right? Without that, they will stop functioning. So, and again, that's the piece that I know that the people who are listening to this understand really well, and just recognizing that it's true for everything in the world.
I think we also believe that entropy doesn't apply to software systems. And that's in some sense true. But the problem is that the rest of the world is changing around our software systems. And so one of the things that I find a lot, both with my own infrastructural systems, and do not ask me about their state of repair, it is dire. Standards keep evolving, in order to cope with, both, the increasing demands on our systems, as well as, increasingly exciting adversarial behavior. So, the SSL certificates that I deployed, 10 years ago are no longer good enough for the modern internet.
Right.
And so the way that, despite the fact that software doesn't rot, basically, we still need to update it on an ongoing basis to cope with the changes in the rest of the environment. And so I often wish that we would stop talking about technical debt and start talking about technical depreciation, because everybody understands when you buy a machine in a manufacturing plant that old printing presses, for example, are still in use and still great, although that becomes increasingly a niche thing. But you are going to need to replace them after some period of time, because they're no longer sufficient to the demands of the market. And
right. So first of all, I mean, the old printing presses, I promise you, have been maintained to for them to still function. Right? They haven't just been sort of set aside, but they are certainly more robust. So the thing that you're sort of describing, I think of as, there's actually two pieces to it. There's sort of the Red Queen effect, the running to stay in place piece of it, right? That everything is changing around you, and you can't just be well, I'm just going to stay here, because you actually do need to run to stay in place. But the other thing that I'm actually going to point out, and this is the one that I know how it applies in the physical world, and I suspect you could tell me how it applies in your world, which is that our standards get higher, right? So a lot of what's changed with our infrastructural systems has been because our understanding and our sort of expectations for the world around us have in fact changed, and we have higher standards. So one of the ways to describe it is like in my lifetime, like the water that I drink, for example, or like the bodies of water around me have gotten noticeably cleaner. And so like the EPA was it's just about 50 years old. I want to say it was like in 1970 or so. And, Boston is famous for how dirty actually many American cities, right? You can think about how dirty like the rivers were, or how dirty the nearby sort of the harbor water was.
There is literally the song in Boston, love that dirty water.
Yeah.
Boston,
yeah, exactly. And like when I first moved to Boston, actually I was doing my postdoc at MIT, and I lived across the river in Back Bay. So like my walk every day was down the river to the nearest bridge, and then over the river, and then down the river to campus. And I remember the first time I saw a bird that I didn't recognize, which turned out to be a night heron, which is like a really striking bird. And it's like, I don't know what that bird is, but I know that bird eats fish, because I could tell, because it has like the sort of spearing beak. And it was an instant indication. Like, I live in the city. I'm used to seeing seagulls and sparrows and robins and pigeons and not much else, right? But seeing this bird was like, okay, there is fish in this river, right? Because that bird is definitely eating those fish. And so the idea, basically that would not have been true, 20 years ago, 30 years ago, and certainly not in whatever the 60s, whenever dirty water was written. The harbor was kind of a mess. And it's only because of these sort of increasingly high standards for things like stormwater separation projects, right? So lots of places, the water, like if there's a major storm, it overwhelms the sewage treatment plant. And so that means that extremely dilute sewage gets released, and it doesn't smell and it doesn't look like much, but it can have significant amounts of E. coli and other sort of pathogens. And I grew up in a place where it was like, if there was a bad rainstorm, you knew that you weren't supposed to go swimming in the water in the beach. And you might hear warnings on the radio not to do that. And so lots of places are like actually figuring out how to do stormwater separation, so that's no longer the case. And so that really is just like, we have higher standards now, right? It's not a running to same place thing. There are those too, but like, it's like, we think that places should be quieter. We think that water should be cleaner. We think that, so yeah, there's kind of two sides to it, right? One is the Red Queen effect that you described, but the other is like, we rightly have higher standards.
Yeah. Sometimes we struggle to enact them. I'm living here in San Francisco, and public toilets would be a massive infrastructural improvement, and we cannot get out of our own way, it seems, to make them happen.
And actually, one of the things that I have talked about is that our primary locus of interacting with infrastructural systems is through our housing. And for many of us during the pandemic, this was really hit home, because it was like, oh, actually, most of our basic needs are met by the infrastructural systems that are embedded in our housing. What that means is, if you do not have housing, you do not have reliable access to those systems. And we're not talking broadband, right? We're talking water and sewage. It really is appalling, but it really, it's not just like, oh, we need more public toilets. It's like, we do not have adequate housing, right? So people do not have that sort of locus of interaction with these systems.
Yeah, exactly. Yeah, we have 9,000 people who need a bed on any given night, and we have 3,000 beds. And so you do the math. Yeah,
and like what they actually need is like toilets and showers, and right, in addition to like a place to sleep. So, but we just sort of take it for granted that
all of that stuff comes along with that roof.
That's right. If you have people talk about a bed, but it's actually the four walls and everything that's in those four walls is also really, really important.
Well, and bringing people together in those places makes it easier to provide them with all of the other services that they might need around, a bed and a roof and, water and sewer, things like food and, access to healthcare and, all that kind of stuff.
Yeah. But even leaving that, even leaving aside sort of the larger things around how the US basically provides or does not treat housing as a public good. But instead treats it as a private good and as really an investment vehicle. And of course, there are people who are actively working very hard to move away from that model, from the sort of housing as a private good and moving towards a housing as a public good model. but we think of housing as a public good in the social sense, and we don't really think of it as a public good in the sort of economic sense of a thing that we want everyone to have access to, that everyone is better for having access to it, and that we don't want to exclude anyone from it.
Right. That point you make in the book about, I think, the residents of Boston realizing, even the wealthy residents of Boston realizing that their lives were going to be much, much, much better if everybody had access to water and sewer was, I thought, really trenchant, because that's a thing that I think we don't always recognize about infrastructure. The sort of corollary of what you say about it being, taken for granted is that this idea also that, like, it is better when it's shared. It is better when it is shared, and it is better when it is shared more equitably.
Right. And so that's kind of there's a kind of a few pieces to it, right? So there's something like water. I said that part of the reason why water was kind of one of the early infrastructures is because of energy reasons, right? Because water runs downhill. But it is also one of the early infrastructures because the case for water as a public good is so obvious, right? And that was a case that basically is what, like, early health campaigners, that was a case that they made to rich Bostonians. It's like, you should pay for this because you personally will benefit, right, from having, if everyone has access to clean water, you and your family will also benefit. And because, waterborne diseases do not, respect, where you happen to live, right? And we actually had a really solid lesson in, how infectious diseases, right, don't, basically these are things that are like public health is a public good, right? Is a thing that we all benefit from. The more of us who have access to public health in the form of clean water or clean air, right, the better off we all are. And in fact, actually, I should point out that there was, in the wake of, like, basically, getting clean water was essentially the, there is there's a solid argument that can be made that we collectively basically decided that we wanted to level up our public health by having clean water for everyone. It is entirely feasible for us to do the same thing for clean air, to basically say we have standards for air that will also reduce, will also increase sort of public health in a way that will serve the public good. So the reason, like, for water, it's super, super obvious that you personally, like, your water will be cheaper, your water will be higher quality, and you will get sick less if you pay into a system that it's like win, win, win. That is less obviously true for other systems, right? Like it's clearly the sort of Metcalfe's law for networks is that the value of a network to you increases the more people are on it, right? So that is an argument for universal provision, right? That if everyone has access to the internet, if I can sell people, or like roads, right? It's like, I can sell more people stuff. I can distribute it. I can, whatever.
And so the reason that the value of the overall network grows exponentially is because that grows as the sum of, if everybody values the network more, the more people are on it, then you take the sum of those over the network, and the value of the network goes exponentially.
Right. But also, like, for any individual person, the value increases the more people who are on it. Right. And that's kind of the heart of something being a public good, right? That the argument for universal provision is that the more people who are on this, or the more towns that the interstate highways go to, or like the more, the more valuable the network is to me.
Yeah.
Like
yeah,
me,
exactly.
me,
yeah.
right? Like
yeah,
me
yeah.
personally.
Yeah.
And
which is why they grow, which is why they're so successful.
Correct.
They're so relatively
easy
to grow because the value proposition for any individual person is so obvious. Yes.
Right. So there's two sort of corollaries that fall out of that, though. So one is, as something goes from being kind of like a niche or a luxury, like, so basically when when only a handful of people had access to the internet, it kind of didn't matter whether you had access to the internet or not. Right. But, and I mean, I was one of those. You might have been too, right? Like, I remember when, like, me and like 5 of my friends had email because I was like in engineering school and no one else did. And, but like, to not have email in like 1987 or like in the early 1980s, and to not have email in 2024 is a very different proposition, right? It's like literacy, right? Like, not, 500 years ago when like 20% of Europe could read, if you couldn't read or write, it wasn't that big a deal. Right? If you can't read or write in 2024, it is a huge freaking problem. And broadband is basically like that, right? It's like, it's gone from like a thing that is sort of like, oh, if you have it, it's kind of nice to have, to a thing where it's like, you cannot fully participate in society without it. There's like that sort of tipping point, right? That sort of, that inversion that happens. So that's one corollary to like, it's not just, it's better if you have it. It's that your life is materially much, much worse if everyone else has it and you don't. Right. So that's one of the reasons why we think of having access to infrastructural systems in many cases as like a political right. I think that we are like, broadband is a human right, mobility is a human right, right? Because we understand that it's not just like, oh, it's like, it's a nice thing to have and you don't have it. It's like, no, now you're actually being excluded from civic society in some way, shape, or form.
Now it's actually worse for civic society in many ways. Like, the city of San Francisco just assumes that there's all sorts of stuff you can do online. There are not offices where you can do it, and they really want you to pay your parking tickets. So they have some incentive to get you access, mostly through libraries, and thank goodness for them. But yes. Yeah.
Right. And that was exactly the thing I was going to say, right? It's like, I, you probably do too. I know a lot of librarians who like, I spend, a significant part of what I have to do is like help people negotiate these systems who do not have like sort of that level of sort of information literacy and that level of infrastructural access. For actually the other way around, they don't have the infrastructural access and therefore they don't have the informational literacy to navigate these systems themselves. And so that's sort of the first corollary to the sort of networks as a public good piece, right? Is that as things become more widespread, there's a tipping point where being excluded becomes much, much worse than it would have been when they were not widespread.
And also because decision makers take the infrastructural networks for granted and so start making decisions which don't consider the absent case. And now,
and there's no, and it may be that there is actually no longer any way to do this without being online, right? Which is the issue, that you're now excluded from social provision or from civic services if you don't have this, because everyone just is like, of course you have it, right?
You can't actually take cash to the impound lot, and there's an office there, but it's an enormous pain in the ass.
Right. Which is the other thing, that infrastructure makes certain pathways easier than other pathways, right? They take less time, energy, resources to use, which is good, right? Which is what we want. But it really does make anything other than the pathways that you use much, much harder. And most of the time that's fine. When we realize that we want to decarbonize and transition our entire technological society, figuring out how to jump the tracks, right? To move to a different track is actually the challenge we have ahead of us.
Although the point that you make in the book, the interchangeability of electricity, is incredibly powerful for that. We talked a little bit about people finding the book optimistic, and I wondered if the publisher maybe should have marketed this book as how we are going to survive and thrive in the 21st century.
Oh, interesting. My brain, you think I would know this offhand. I feel like the UK subtitle is a little bit closer to that, and you'd think I would actually know what it was. But part of the reason why I can't remember is because I actually worked really hard to go away from the framing of we need to understand these systems before it's too late. Because the sort of catastrophic framing and that sort of conflict and the sort of like bad things will happen is so powerful. And I am
It sells a lot of books, but it's also exhausting. Especially if you're working on these systems where I'm like, I know all of the problems that you're worried about. I'm worried about, the day-to-day problems, which you don't even know about. And then there's trying to get through the day.
Yeah. I mean, so one, I think the emotional, the affect of it. But the other thing is just that I think that everyone kind of knows what the problems are, but I think that for lots of reasons, we are much less, tuned into the idea that there's actually a path forward.
Yeah. And we're on it.
Right. And we're absolutely on it, about building something better rather than averting catastrophe. Right. And building something that we feel is better is way more motivating than part of this is because I spent a lot of my time with undergraduate engineering students. Right. So I spent a lot of my time with 18 to 22-year-olds. And I don't want to tell them that your entire life is going to be cleaning up the mess that the adults made.
Your grandparents and great grandparents left you. Yeah.
Yeah. And you could absolutely frame it that way, right? Except that I think that that's actually not what I'm asking them to do. What I'm asking them to do is to build this better world for themselves, for everyone else on the planet, for all other life on the planet. And as a side effect, they will address the issue of climate change. And as a side effect, they will address the issue of pollution, like actual physical pollution in our environment.
Well, and the idea that much of this work is already in progress and we need to contribute to it and we need to push it along rather than needing to make it, happen from nothing is
from
huge
nothing. And in fact, actually, because people have been working on it really hard for the last, 40 or so years. So minimally, I think about, the one thing is, I'm not old enough to remember this, but I know that Jimmy Carter sort of famously said during the oil crisis that you should wear a sweater, right? Turn down. And that's because in the 1970s, the only way you could get energy was by combustion. And that is not true in 2024 because people put a huge amount of time and energy into developing commercially viable solar panels and things like, the standard Danish wind turbine, which is the one that we see everywhere. And, things like geothermal and none of these is a silver bullet. Right. And actually, a very sort of little appreciated thing is the concerted amount of energy of effort that went into going from incandescent lights that basically produce heat and then produce light as a side effect, right, to LEDs, which basically just move around electrons and get photons, right? The incredible efficiency of LED lighting compared to incandescents. And it basically was, we're going to support the development. And if you remember compact fluorescents, which could screw into a light bulb, but which were terrible, right? And then it's and now LED lighting is so great, right? It's the color ranges that are available and they use so much less energy and they look so good. And except for very specialized applications, LEDs are almost always a better choice than regular light bulbs. And then of course there's the myriad things you can do with LEDs that you couldn't do. I have a little tiny LED that runs off a button cell. And in fact, I use rechargeable button cells, right? That lives on my keychain, right? That's a source of light. And there's no, I would never do that with a flashlight, right? And all of this is because of people who have recognized that we want to create these technologies to make the world into a different and better place because of how we handle energy. And we now have, we've done so much of this work. And now it's sort of time to figure out, okay, now that we don't, it's not like it is the tools we need, is the pathway forward, but we have a set of tools and a pathway forward. And that's enough to get going, right? That's enough to be okay, let's move into renewables, right? Let's phase out combustion. We don't have to turn the heat down because we can get energy and by bypassing combustion. But we, the way that we take care of each other and the way that most of us get our agency to act in the world is through these infrastructural systems. And we have what we need to decarbonize them. Let's do it. Right. So yeah. And make it happen for everyone. Right. And take advantage of the sort of physical affordances of decentralized, abundant, distributed energy that we turn into electricity and then use for literally kind of whatever we want. Right? As opposed to having to pass through the incredible thermodynamic inefficiency of setting it on fire first. Right. And then doing whatever we want. Right. And, it's solar panels. It's here's photons and here's electrons, amazing. Not you set it on fire and you turn a turbine and then you the turbine turns into magnetism and then it turns into pushing electrons and then you get photons.
Yeah.
Right.
Yeah. I think you make the point in the book that the biggest problem a lot of these solar farms have is keeping the dust off the panels.
I would say I think the biggest problem is the sort of storing and generating. The real problem is that it's this is kind of hilarious, right? This idea of it isn't, solar panels produce so much electricity that we're not going to make money because we could only sell the electricity for really, really cheap. And it's that is not a problem. That is the dream, right? The dream is too cheap to meter, right? It is only a problem if you think that someone should be making money off of it. If you think of energy as the thing that underpins our agency in the world, right? That allows us to do things like closed materials loops, right? To not pollute. It's that is freaking amazing. That is the best argument for public power I've ever heard, right? It's like, we have so much power that we can't make money off of it as investors. And it's like, yes, right? That's why we should invest in it as a society. So that, I would say that is one of the big problems with solar. And we know we're working on things like grid scale storage, what we're really working on is things like the distribution, right? It's like, how do we buffer energy generation over time, and how do we buffer it over space? And again, it's like we kind of know how to do this. We just need to figure out how to modify, like how to change the sort of social and economic and political systems around energy to, it's not like we don't know how to build it out physically, right? As a technology, like we can build smart grid. We're just trying to figure out like who's going to pay for it and how, right? And that is a tractable problem. I mean, that is a very different problem than, like, you know, how do we get enough energy to run the world, right? It's like figuring out who pays for it. It's like, we should be able to figure that out.
We should be able to figure that
right?
out. Yeah, I do. I don't know. That's where I feel the most sort of like frustration is around the, you know, I was talking about the San Francisco sanitation issues and our inability to get out of our own way on it. And that's, I think, where, you know, the corollary to infrastructure systems being taken for granted is that, like, any kind of modification to them is seen as enormously threatening because we have to think about them for the first time in maybe our entire lives. Like, oh, there's a seawall. I didn't realize there was a seawall. That turned out to be a pretty easy sell. Not getting flooded turned out to be relatively easy to get a bond measure passed on. But
yeah, because everyone can kind of see the public good element of that. When
you can kind of see the public good element of it. Yeah.
Although, I mean, personally, I think
it's going to flood.
Right, but I mean, also, I think if you live in San Francisco, you should absolutely see the public good of like sanitation and housing at this point, right? It's like this thing, right?
I've been saying,
like, I mean, right, like people. I've heard. I mean, I live 3,000 miles away, and I've heard people complain about it enough that you should absolutely 100% realize that it is a public good that everyone has adequate sanitation. And, like, it is like, you know, it is like the definition, right? It's like, you do not want to exclude people from it and your life will be better because other people have access to it. Right.
In a really material way.
Right. Like, this is the thing. It's like, what more evidence do you need? So, but this is the thing. It's like you know, this is genuinely unprecedented, not even in human history, but in our, like, as humans, as a species, right? We have only ever gotten energy in huge quantity, in like significant quantities through combustion, right? And I mean, and so the idea that we can bypass combustion to get our energy is like a thing we have not fully wrapped our head around the ramifications of that.
Or chemical energy, like, one of the things that I say about the 20th century is that it put more kilowatt hours in more hands than ever before. Because, you know, even in my grandfather's era, he used a horse-drawn plow for, you know, the early part of his farming career in Iowa in the, what was that? Like the 40s, like after he came back from the war, he was still using a horse-drawn plow.
That late 40s, early 50s, yeah.
Yeah. I know because I would play on it when I was a small kid and visiting grandma and grandpa. And it was, you know, the explosion of chemical energy from oil, you know, and the, you know, increasingly ubiquitous ability or availability of the internal combustion engine that, you know, but before that, you know, it was steam power, and before that,
which is powered by coal.
Coal, yeah. And before that, you were limited by, you know, the chemical energy available to you, your family, and your draft animals. Like,
yeah. So, I mean, there's a couple of different pieces of it, right? So there was always the sort of biological chemical energy, right, that comes from food. And like, you know, a lot of human history has been basically not even just animals, but actually getting other actual humans to do work for you, right? And
by better and worse mechanisms, but
yeah, and like some of the mechanisms are like historically the worst mechanisms ever.
Yes,
right.
Yes, and on the flip side, like the pyramids, famously not actually built by slaves, and so you can do enormous things with human labor.
Like lots of Europe and you know, basically like a lot of colonialism and like basically slavery was about like getting other humans to basically to put in those energy inputs that you could then benefit from. the thing that if you actually, you can look at the graph of the IAEA has the graph of energy that's used by humans as a species, and it's exponential. It basically, that's not true. It was a flat line until about 1700, right? And then it becomes exponential. And most of what's powering that, you can sort of see, it's like, here's where the coal came in, here's where oil came in, here's where natural gas came in. And then you can sort of see like nuclear, hydro, renewables. But that baseline was kind of biomass, right? It was powered by, combustion of biomass. And the food we eat. Like humans are basically, how to white light bulbs, which actually don't exist anymore. But like, we're basically televisions, right? Like we don't actually use that much energy.
No, I say we do everything we do on half a hamburger.
Right. Yeah, absolutely. Yeah. So, if you think about like, the RDA is like whatever, 2,000 kilocalories a day, and you can convert that, you can figure out what that means in terms of power consumption. And it is about 100 watts, right? It's about 100 joules a second. And, so fossil fuels actually were like the energy, the exponential growth of energy usage. And in terms of like how much energy we use as individuals, right? Our energy footprint, is mostly powered by fossil fuels, but we're now at the point where it doesn't have to be, right? Where we can decouple that. But yeah, like the real, when we talk about like the global south, and we talk about like developed countries, and we talk about like rich countries, right? Like this is one of those, like I'm an engineering professor, not an economist, because I don't think of that in terms of GDP. Right. I think about that in terms of per capita energy footprint.
Yeah. Although they correlate real closely.
That's correct. And They don't actually correlate perfectly, but they correlate very, very closely, because the thing that you do when you have more money is you spend it on more energy so that you have more agency in the world. And really the thing you spend it on is collective ways in which we use energy, whether that's like electricity generation or transportation, right? It's like, it's not.
Well, because that levels
right?
everybody up,
is,
and you get the exponential growth curve from that.
That's right. It's like, it's not like individual people are using so much more energy. It's that you build coal-fired electricity generation, and then people use the electricity to do the things that they want to do. I really love Amartya Sen's The Development of the Economist. He describes it as, we want the freedom to live the kind of lives that we have reason to value. So it's not a one size fits all. You get to do X, Y, and Z. It's that money he's an economist. For him, money is what lets us do this. I'm an engineer and I study infrastructure. So I think about the energy and infrastructural systems that enable us to do this, to give us the freedom to live the kinds of lives that we have reason to value. And I really want that for everyone, right? Not just people who happen to be born in places like Canada. It is now eminently doable, if we figure out how to actually do it.
That analogy you have in the book of the black start, where to set the stage for people who have not read the book, there is one of the ways it turns out that we store electrical power at grid scale is what's the term for it?
For like pump storage hydroelectricity,
yes.
Or do you mean that? Okay, yeah,
pump storage hydroelectricity. And so I don't know how you pronounce it. I think it's Welsh, Dinorvig. Dinorvig in Wales.
Yeah. I think I'm not a native Welsh speaker, but I think that's.
Okay. There is a big mountain with two reservoirs, a big reservoir at the top and a big reservoir at the bottom. And when they have excess electricity, they pump water from the reservoir at the bottom to the reservoir at the top. And then when they need electricity, they run it through the turbines. And the falling water generates electricity. And in the event of a total power outage, they have a backup system, basically. I forget if it's a gas generation or...
So it's like, assuming it's diesel, it's usually like a diesel generator that produces enough energy to open the valve, right? So it's like, this is the water runs downhill thing, right? It's like, you don't have to move the water around. You just have to open the valve, right? At the top. So if you can produce enough energy with your diesel generator to open the valve at the top, then you get 6 hours of power by the water, like rushing from the top reservoir to the bottom. And that is enough electricity to reboot the grid as a whole. And so this is what's called a black start for obvious reasons, right? Because it's dark when you start, and hopefully if you get it right, it isn't. And so the metaphor that I've used is, you have these diesel generators, and the point of the diesel generators is not to run your grid off them. The point is to open that valve so you get the renewable energy and you can boot the whole system up. And the metaphor, yeah, right. And so the metaphor I've used is that fossil fuels were basically the black start for humanity. They gave us enough energy in a concentrated enough form that enough of us had the leisure to be like engineering professors, right? As opposed to like working in the field. And you and I are both like, not very many generations off, right? Subsistence farming. And in my case, most people who look like me on the planet, right? Brown, middle-aged woman, this actually, basically taking care of their daily needs, like water and fuel for cooking, that actually is their life still, right? It's not just, my grandparents or my great-grandparents. It's like, actually, most women on the planet, this is what they do. But the black start is that if you think about fossil fuels as being the black start for all of humanity, that it gave enough of us the leisure to figure out what the next thing is, and to get to the point where we have the sort of space and time and knowledge and ability to collaborate to create these technologies that enable us to move towards using energy in a way that is aligned with our actual planetary boundaries, right? Which is, there's an infinite amount, there's like solar energy arriving at any moment, every moment of every day, right? It's not a thing that we're not,
never going to run out of it within our lifetimes or 1,000 generations.
That's right. That's right. In a couple billion years, the sun will actually basically turn into, it won't actually go supernova. It'll just burn out. So
I think
it'll end up with a red giant, then brown dwarf.
Yes.
And, I mentioned my undergraduate degrees in engineering physics, and that included a decent amount of nuclear astrophysics. So I think that, I believe that we need to work on like long time scales, and I'm okay with that as our long time scale.
Yeah,
frankly.
exactly. Yes, yes. My grandchildren can work on that.
Yeah. And in fact, actually part of our job is to make sure that our grandchildren get to have,
right,
the leisure
to work on that.
To work on things like what does it like interplanetary space exploration look like? So basically if you think about fossil fuels as the black start for like all of humanity to get us to the point where we can actually build out these renewable systems, this alignment with our planetary boundaries. But yeah, unlike the diesel generators, you want to turn them off. They're like loud and expensive and polluting and noisy. And it's like, you do not want to run those forever, right? You want to you want to get the hydro going. You want to get everything else going. And same thing with fossil fuels, right? It's like that got us up off the ground, gave us like the space and time we need to do stuff. But now it is time to turn them off, right? And to transition to our renewable energy. Yeah.
I think I grew up reading the Jimmy Carter era, just put a sweater on kind of people. And so the vision for a future that was, renewable and sustainable was kind of a pastoral vision, maybe not an entirely realistic one, certainly one which, coming from a pastoral place and being able to smell all of the problems with it, did not enormously appeal to me. So I, worry when we look at that exponential curve of energy growth that we will just always be able to consume as much energy as there possibly is. We will never satiate ourselves, basically. But the point you make in the book that at least in terms of human consumption, we do find that there's kind of a sigmoid, and most of us in the developed world are somewhere towards the top of the sigmoid. People, who are still getting access to these infrastructural systems are still in the exponential part of the sigmoid. But that the examples in my head are things like leaf blowers and jet skis, which are
right,
maybe
recreational uses of energy. Yeah.
Yes.
Yeah.
Recreational uses of energy that I find really obnoxious, and I'm like, we could do less of that.
But civil aviation is actually kind of the important one, right? Because as individuals, that actually is a significant amount of your energy usage. It's just that globally, civil aviation is not. It's only like a few percent of our global energy usage.
It's 3%, I think, is the number that sticks in my head.
Yeah, it's kind of under 5 for sure. Yeah. And but as an individual, it can be because it's like. It kind of makes sense when you're like, okay, it's not that it uses that much energy. It's just that you just go really far and you go a lot, right? And it's because you're sharing that energy, like compared to a car with like 1 or 2 people in it, right? You're sharing that energy with like, a couple hundred other passengers. And of course, everyone has, it's not like airlines don't have an incentive to make it efficient, right?
Oh my
it's
God,
like, because every joule you spend costs money and someone has to pay for it.
Jet fuel is their biggest expense. They're enormously incentivized they're enormously incentivized to optimize that. Yeah.
So like, unless you have a private jet, right? Like you do kind of max out sort of how much energy that you can use. But I think the point though is that we, energy is in a very real sense agency, right? We're physical beings in a physical world. And that means to do things, we need energy. And so we have recognized by saying, oh, we're going to use less energy, people intrinsically understand that means they're going to have less agency in the world, right? They're going to do less, don't travel, be cold, right? All those things. And there's two ways to get around that.
Civil aviation is emotionally the thing which, that's the thing you will pry from my cold dead hands. Yeah,
I mean, I was saying, I'm an immigrant, I'm a child of immigrant. And in fact, I actually had, no one in my family, none of my, most of the people I love do not live anywhere near where I live. And including my family, right? My immediate family, including my niece and nephew, including most of the people who are close to me. And I actually had, I know what it was like to not see them for 15 months, right? And in the most traumatic way possible. It was not.
Yes, that sucked.
Yeah. It was, and I think civil aviation and, actually understanding that we are a single connected polity, right? That we're all people on the planet is actually really important. Basically, I don't fly from Boston to Washington, DC. I take the train, but I'm not going to stop. I mean, I feel like people who say you must stop flying. It's do you really understand how big North America is? Or do you have are there any immigrants in your family who moved from the other side of the planet? There's basically two things you can do, right? One was always use less, right? The other piece of it was efficiency. And that's actually where things like LED light bulbs come in, right? It's it genuinely is, we're not doing less. We're actually doing much, much better, right? Where light bulb, light is genuinely better than it was 30 years ago. And including the fact that you can't burn yourself. I mean, yes, your easy bake oven now has to have a heating element because you can't just do it with a 100-watt light bulb. It also means you can't burn yourself on a 100-watt light bulb, right? They actually got phased out. Most people probably don't know this. They actually got phased out because they're actually dangerous, right?
Oh, the halogens that used to be in those tertiary lamps.
God.
Yeah. They used to have.
I forgot about that. In this transition, right?
Yeah,
I forgot about halogens. Yeah,
used to have the metal grill over it so that if something
to make
fell
sure that no one
into
could touch them,
and so that if something fell into it, it would be less likely to catch on fire. Yes.
Yeah. So there were we went through a couple of really terrible things to go from incandescents to LEDs, and LEDs are great. So that idea of making things efficient is definitely part of it. I'm not saying we should not make things efficient, and moving to public transit instead of cars is a good example of yes, it is much much less energy intensive to have public transit, but it actually is better in many cases.
God. Coming from Boston to San Francisco has been kind of traumatic because, the MBTA in Boston is struggling now more than it was when I lived there. But if you have never had the experience of a good public transit system, it is joyous. That is my uncle was actually talking about, they just built a train system in Denver where he lives. And he was the first time he rode the train from his place, to the city to go, he's now got season tickets to the opera or something. Cause, he can do that. He can just, and he was the first time I rode it, I was, wearing a mask because it was COVID times, but underneath the mask, I was just grinning ear to ear because it was so joyous to have that agency, like you say, without.
Right, because it actually genuinely is I could just walk out the door and get on the sub, whatever, and I don't have to worry about parking, and it's way less expensive. So actually, it's funny because the two things I'm going to say is I'm going to put a letter of recommendation in for there's a podcast called The Big Dig that came out of one of the Boston public radio stations that is about burying the big highway, the sort of multi-year project, and it's some parts of it are terrible, and it kind of ends with. And now we've actually made the Rose Greenway and we've opened the Green Line and it is genuinely great, right? It's people but in fact, I actually talked to, an academic advisee who's actually not one of my students, but is actually a student of a close friend of mine who lives in the Inland Empire, in California. And she went to New York for the first time. And she was oh my God, the subway. And now she's about to go to grad school on the East Coast. And just I don't have to have a car. I can take public transit. sort of joy. Like it is because public transit scales with people, the number of users, in a way that cars do not scale. But it's a perfect example of like, you can make things more efficient and less energy intensive, but actually also better, right? Public transit is like LED light bulbs. And we have made the investment
for moving people around.
That's right. So we have made the investment to create LED light bulbs, and we're figuring out how to make the investment to do things like more efficient alternatives to our infrastructural system that are also better, but they are out there, right? They are not, it's not like, oh, we don't know how to do it. It's like, we're figuring out how to pay for it. We're figuring out how to get agreement around it without imposing that on people, which is what happened with like highways in the 1950s, right? That's the work, right? That's the thing we're trying to collectively figure out.
And the amount of engineering it took, there's a PBS special that I watched. I haven't checked out the Big Dig podcast. I will check out the Big Dig podcast because like everybody in my life has recommended it to me at this point, and it's obviously on brand. But like the amount of engineering they had to do to make the Big Dig not disrupt traffic in the city of Boston, they were like literally freezing the train yard at South Station, or trying to
drive
the tunnel
the
under
ground
it.
underneath it. Yes, absolutely. And that actually really, I mean, I'm doing a time check. That really highlights a really great point, which is the using the energy and the resources that we have to mitigate harms rather than just making them somebody else's problem. And we are incredibly good at doing that when the people who are benefiting from the system we're building and the people who are getting harmed by the system that we're building are the same people. And we have historically been incredibly bad at doing that when we could make other people deal with the harms. And there's no other people. We live in a globally connected world, right? So, but we also like have access to energy and technology in ways that were unprecedented. So we can really be like, okay, instead of trying to make systems where like, well, it's utilitarian, it's like the harms to a few outweigh the benefits to many, or often it's the harms to many outweigh the benefits to, or basically considered on par with the benefits to a few. We can actually say like, we're going to build, instead of being utilitarian, we're going to be an ethics of care. We're going to think about how do we mitigate the harms? We're going to think about who gets harmed, who is vulnerable, right? What are the things that folks need? And really sort of reframe the implicit, for lack of a better word, philosophical basis behind these systems. And that was hard to do when everything was expensive and scarce. And the sooner we move to a world where we're like, no, actually, we live in a world of abundance and not a world of scarcity, and we have access to all the energy we need, right? The easier it will be for people to recognize that we can actually build a world where we not just rich people mitigating harms for rich people, but we can actually mitigate harms for all the systems that we build.
Yeah, interesting. One of the things that has frustrated me a lot out here are the ways that, in the name of mitigating harms, a lot of good things like, building housing, building these, building shelter for people who need shelter has been blocked. And some of that is mindset shift. Some of that is, I don't immediately see ways, to use energy to, ameliorate some of these things, although it's probably there, but
yeah, I mean, that's things like my property values are going to go down if there's more housing. Right?
Yeah. Or my window is going to be shadowed now. Shadows are a big thing here in California.
Yeah, I mean, and I don't mean to the human things are real, right? I don't mean to oversimplify them, right? But our starting point for how we address them is a very different place, I think, than people largely think it is.
Yeah, well, and the point you make about, I think, everybody operating out of a scarcity mindset is part of why these conflicts feel so intractable. And to some extent, that's because we are still in the takeoff curve, and, a lot of these things still are scarce. Apparently, construction costs have gone up like 3 or 4x in, the Bay Area since, 10 years ago. And so, which is, materials availability and all these kinds of things, labor.
Right. But
costs.
It's also labor. It's also like and as someone who's a professor at an engineering school, boy, do I have opinions on like what we basically the sort of under appreciation of the trades as as sort of pathways, but I feel like that's probably a whole other podcast.
That's a whole other podcast.
So,
yes,
right,
definitely.
about sort of the way we I mean, again, I talked about the sort of the brain on a stick, right? That we can think of the digital world and like being knowledge workers because our needs are so well met that we don't think of them as physical material. And I think there's absolutely a very similar sort of hierarchy with the like, do you do work that's like knowledge work that's like ephemeral and digital versus do you do work that is embodied in material? And it is, it is a hierarchy that does not and should not exist for a bunch of reasons, including one that there's like it's not intrinsically smarter or more, one is, easier or harder, right? And it's a fully artificial and now actually, not just as an artificial hierarchy, but I think we are all doing badly by that hierarchy, right? So
it blinds us to the actual structures of the world, which we need to understand in order to do those ephemeral digital jobs better.
Right, but also like there's lots of people who would be well served by like having like doing like jobs that they're like solving problems with their hands. And we don't have a lot, we don't have very good pathways for people to go into those directions. And we also have the like, oh, if you're smart, you shouldn't be in the trades. I actually took electrical and auto shop when I was in high school, and I was really aware of the fact that I was the only girl. And I say girl because I was like 13 and in those classes. And it wasn't until a long time after like literally probably only like 15 years ago that I realized that I was actually the only kid in the gifted program at my school who took auto shop and took electrical shop. And that was an actually even more profound difference, right? The idea that if like smart kids don't take shop, not just that girls don't take shop. And both of those are like incredible, like neither of those serves us well. Right. And, as a society or as individuals.
I don't know about you, but I've found the moments in my career where I have gotten to do things in the physical world, it's, growing up, like you say, the ideal was to have a white collar desk job. And now anytime I can get out from behind my desk is an enormous, is an enormous relief because, one of the pathways that a number of my high school classmates followed was to go into the trades or work on farms or, military or all these, enlisted military, all these kinds of things. There's a lot of value in that work. And
and we need it. Like we especially need it right now when we are like talking about like rebuilding the entire technological basis of human civilization.
Deb, this has been really lovely.
Thank you.
I have really appreciated this conversation. I feel like we could have another hour and a half conversation easily, but which makes for absolutely the best kind of conversations and podcast episodes. Deb's book is How Infrastructure Works. Inside the systems that shape our world. Deb, any parting thoughts?
I think it's all, I think the most important thing for me is to never lose sight of the fact that this is about, it's not about averting catastrophe. It's about creating this better world, but also, to not lose sight of the fact that these are infrastructure systems are inherently collective, which means we can only transform them together.
Yeah, that's big. Both physically as well as like intellectually. Yeah.
That's right. Yeah. So Kevin, thank you so much for the invitation to be here today.
You're very welcome. Yes. This has been a ton of fun. Where can people find you online besides on Amazon and other book things?
So speaking of infrastructure and like being, having mine. So I have a newsletter called Meta Foundry that was on Tiny Letter, which has gone down. So I'm in the process of migrating it to Button Down. And then similarly, I used to be on Twitter and I'm really not anymore. But if you can find me on, Mastodon right now, I would say your best bet is probably finding the book, but fairly soon, I hope, my online presence will be kind of rebuilt from now that the systems underneath it that we take for granted.
There we go.
And now finding a new way to build it. But I'm eminently Googleable, and eminently findable, on the internet. And and I'm also kind of embarrassed that to look face on at my infrastructural systems. So
exactly. The shoemaker's children always go barefoot. Also, all of the links for all of the book shops will be in the description, as well as at criticalpoint.tv/infrastructure. So you can find her there in digital, physical, and audio. Thank you so much, Deb. Really appreciate this.
Thanks.
And,
Thanks for having me come in.
Yes. Take care.
Okay. Bye.
Thanks so much for watching and listening. If you liked that, please like and subscribe down below, or rate and review us if you're listening to the audio version in your podcast app of choice. If you'd like to buy a copy of Deb's book, links to all the versions, including DRM-free audiobook, are available at criticalpoint.tv/infrastructure. If you have an incident story you'd like to tell, please email us at hello@complexsystems.group. You can find me on Twitter as @KevinRiggle, as well as all the other social networking sites. Intro and outro music is Senpai Funk by Paul T. Starr. My consulting company, Complex Systems Group, is on the web at complexsystems.group. And with that, folks, till next time.